Which of the following statement is not true? I think the question is some problem. Should be true. Which of the statement is true?
All right, doctor. We already have the winners. All right. The first winner is Anis Gani. The second winner is Chachi. Congratulations for both winners. Back to doctor.
Okay, thank you. So which of the following parameter is not needed is halving constant. And which of the following statement is true? The viscosity molecular weight fall between number average and weight average. So with that, I end my presentation and hand over to. Oh, before that, any questions?
Okay, we have one question.
Okay.
What solvents are suitable for NBR latex fractionation?
Oh, for NBR, you can use cyclohexane. But NBR normally have a lot of gel. You got to remove them. So gel it also affect the gel actually is a cross-link entity. So it's already cross-linked, right? So you also affect the processing behavior of your rubber because the amount of gel will determine how much cross-linking is your raw material. So if you high cross-link in your raw material, then you probably do not need a lot of cross-linking reaction. So gel is also important, the gel content, which due to the lack of time, so we do not discuss it here. Now it's already 12:30. Originally, you planned for 7 video, probably it's too long. Probably 4 or 5 just in. Any other questions?
Okay. How to calculate ionic and covalent cross-linking degree?
Oh, to calculate covalent, you do the overall cross-linking by using the good solvent like cyclohexanon, ketone, cyclohexanon. I presume you talk about NBR. Okay. Then you add some polar solvent into your solvent like cyclohexanon ketone to dissociate the ionic crosslink. Then you determine the swelling again. Okay. So by adding the polar solvent like acid, organic acid, maybe dichloroacetic acid or something like that, you will dissociate the ionic crosslink. You only get the pure covalent crosslink density. Okay, so you have total using cyclohexanon ketone, then you have cyclohexanon ketone plus, let's say, dichloroacetic acid. Okay, then from the difference, you get the ionic crosslink. You can get this from the literature. You just Google search. You can get the detailed information. Other questions? As I said, now we many good instruments, advanced instrument, viscometry method may not be popular this day, but nevertheless, this is a simple method. As you can see, you just measure the flow time, and the viscometer is cheap, right? So you can easily perform. Let's say your lab does not have good instruments, then you can use this method to determine at least qualitatively your crossing density, your branching density, all this. Give you some good information too, and also the molecular weight, right? So if there's no other questions, maybe our sponsor will have some presentations, right? Is anybody from the sponsor ready to give presentation?
Yeah, Dr. Eng, yeah, maybe I can share my screen. I have prepared it as well. Yeah.
Okay, let me exit my first. Okay, over to you.
Yeah, thanks, Diane. The organizer, do you need us to pass to you, or I can just?
No, you can share. I think no problem.
Yes, you can start.
Okay, can then. So, very good afternoon, everyone. Let me introduce myself a little bit. I'm Renee from Bruker, Malaysia. I'm not very sure if everyone know about Bruker. We are actually a German company. We mainly supplies for scientific instruments. We've been enters the field of FTIR spectrometers since 1974. So the very early instruments set new standards in research with evacuables, optics, high resolutions, and automatic range changes. So maybe I do believe some of you can be quite familiar with FTIR spectroscopies. Some might not. So actually, FTIR spectroscopy is widely used for raw materials identifications. For example, if you have a lot of unknown samples, no matter it's from polymers or it's actually from rubbles, you can easily identify them with the FTIR spectroscopies. So FTIR spectroscopy, it can be used for raw materials and product quality assurance. And it also can be used for failure analysis. If you find that if there is any contaminations on your samples, on your products, then you can cross-check with FTIR to identify the contaminations which causes the failures. And you can even use it for reverse engineering if you are in it. And also it will be capable to help for product developments, formula setups, or those. So to analyze with FTIR spectroscopy, it's very simple. You can just put your sample on the measurement channels, either it's from transmissions or ATR. Then you can click on the measurement buttons. Then you will be able, you put on the measurements channels, and then you click on measurement buttons. Then you will be able to get the sample data, which we call spectrums. So together with the comprehensive software available nowadays, user can easily know the identities of the unknown samples via library search with the database. And you also can understand your sample qualities, the purities, the uniqueness of your samples by using the spectrum comparison with your master batch. So you also can, it can also be used for polymer samples as well. Yeah. So it can be used as well for quantitative analysis, where you can use it for concentration studies on your materials. So you can see once the method is being established, this is one of the examples where it's used to study the percentage of PP blend in samples. And it as well can be used to study the concentrations of the LDPE in your formulas. Yeah. So once the method is established, user could use it for the routine analysis for the predictions of such your interest compounds concentrations. Yeah. So if you would be interested to understand more how FTIR can help for your routine analysis, you may contact me, Renee from Bruker. This is my email address and my phone numbers. And you can as well contact our business partner, which is Kinematic Resources, Sokmeng, with her contact numbers stated below. Yeah. So nevertheless, I would like to actually share you one of the applications videos that it will show you regards the capability of our Bruker FTIR microscope Lumos 2 for some of the analysis that you might interested. For example, the fish eye analysis. So this will be the video that I would like to play. Yeah, so this is one of the samples that we'll be using. We would like to understand why we have such a structures on our samples. So this is the IR microscopes, where you can use it for your failure analysis, for your micron size sample analysis, contaminations. So this is once you locate your interest point or locations for measurements, then you can instruct the software to start on the measurements on the area. So this is an area measurements where we want to see the chemicals around this area. So this analysis is performed by using Etr measurement modes, and our Etr is actually inbuilt, so it's fully automated. So this is the data collections where you can see that it can be very fast, over 1,000 spectrums. So by then, with the comprehensive software, you can easily identify where is the failure part or the contaminations. So this is, you can identify what exactly is this compound by subtracting your contaminations to your coatings. Then you will be able to get the identities of your contaminations. So you can clearly see the difference between the two spectrums. With the subtractions functions, you will easily extract the content from the mixture. Then you will get the impurity spectrums. So by searching through the library with your contaminants, contamination spectrums, you will be able to find what is the cause of contaminations. So for example, in these samples, we found that it's silicon-based degradation products. So in fact, it is the silicon oil. Yeah, it's due to the chemical process and the thermal treatments caused this composite. Yeah, that is all I would like to share to you all. Yeah, and then at this moment, I can hand over the stage back to our organizer.
All right, thank you, Ms. Rainey, for the amazing sharing. So there's actually another 2 questions for Dr. Ng. Dr. Ng, are you still there?
Yes.
All right. One of the participants actually asked for tensile testing of sample latex compounding for dipping product application. The thickness used for tensile should follow the thickness in atmosphere of 412, which is 2 mm, or we have an option to do the thickness following the standard dipping product.
What atmosphere? I don't quite understand the questions. Could you repeat?
The thickness used for tensile should follow the thickness in 2 mm, or we have an option to do thickness around 0.4 until 0.6.
If you measure tensile, probably if you want to get higher tensile, actually thinner is better.
Thinner is better, okay.
Yes, theoretically, it shouldn't be any difference. But in actual practice, actually thinner sample, you get better tensile.
So a last question here. To determine the maturation period of latex, we need to do swelling index analysis by calculating the ratio of dry and swollen sample based on diameter. However, how to get the constant diameter as the size decreasing since the solvent keep evaporated during the process?
Then you only need to fix certain time.
Okay.
For example, you fix, let's say after 1 hour, you take the measurement. Of course, you continue to swell, but you need to, for comparative reason, you stop at, let's say 1 hour. Then every time you do 1 hour, you don't go and change your time, okay? So timing is important because for wet gel, you don't you don't take the maximum swelling, you take the swelling after certain period of time only. Let's say 1 hour, you fix at 1 hour. So every time you just fix at 1 hour, that is good enough for you. If let's say 1 hour you get certain swelling and it's good for your production, then you just use that as a criteria. And maybe you just have some specifications. Let's say 120% is good for production, then maybe you want to know if 110 is good also, or 130 is also good. From there you establish a range. What is an acceptable swelling ratio good for you? But of course you need to fix the time. I think normally you can fix at 1 hour. It's probably good. Of course, the swelling will continue to change, continue to increase, because as you continue to allow it to in contact with the solvent, it will continue to swell. As you can see in my today presentation, you want to get maximum swelling, you need to wait until at least probably 1 day at least, or 3 days, or sometimes up to 7 days. So you want to do a short, quick test, then you got to stop after, let's say, 1 hour.
All right, thank you, Doctor. And thank you once again for the great sharing from Miss Rainey, from our representative from Bruker, Malaysia, Sdn Bhd. All right, we have come to our end. Okay, now we are at the end of our program. We would like to invite our President of Postgraduate Chemistry Club, PCC, Ms. Nabila binti Hauzin, for the closing remarks. Welcome.
Okay, thank you for our MC, Ms. Shiba. Assalamualaikum and good afternoon, honorable guests, ladies and gentlemen. On behalf of a Postgraduate Chemistry Club, I would like to express my appreciation to our main sponsor, Institute Kimia Malaysia, organizing collaborators, Kinematic Resources Sdn Bhd, Bruker Malaysia Sdn Bhd, Institute of Materials Malaysia, our invited speaker, organizing committees, Postgraduate Chemistry Club, Institute of Materials Malaysia, and Universiti Teknologi Mara. I'm very pleased with this workshop, which provides us with an invaluable opportunity to share experience and information on rubber. All the presentations and discussions made during the workshop were very informative and enlightening. We appreciate very much your active exchange of ideas and views on how we could effectively address and fill in the gaps in this area. Also, I would like to take this opportunity to sincerely apologize on behalf of my team for any inconvenience experienced by you prior to or throughout this workshop conducted. Your precious feedback is greatly appreciated to improve our performance in the near future. We hope you enjoyed our workshop and had a fruitful session today. Finally, we hope the best for you and success in your future. Therefore, I hereby officially announce the end of the workshop on analysis of rubber without using instrument today. See you in our next event. Thank you.
Thank you, Ms. Nabila, for the warm messages. All right, now we would like to have a photo session with our speakers and participants. Please turn on your camera. We'll have a photo session. Okay, I give you another 1 minute to get ready. Please open the camera.
One, two, three. Another one. One, two, three.
All right, a reminder for attendance. We already put the link in the chat box, or you can scan the QR code given. For those who are already in the participant WhatsApp group, we will also share the link in the group. So don't forget to fill in the feedback from the first to get the e-certificate. And for the winners from the quiz session, may provide your full name and number in the chat box for the prize. And last but not least, thank you for all participants who attend this workshop. We hope that everyone gains valuable knowledge from this workshop. And reminder again, please don't forget to fill in your attendance from the link in the chat box or the QR code given here. For those who are already in the WhatsApp group, we will also share the link. And stay safe. See you again. Bye-bye. Have a nice day. For the winners, you may laugh now. Thank you for the cooperation and congratulations